Hey everyone. So I've just made this email categorizer over here, and the goal of this email categorizer is that it can classify your emails into 6 different categories based on the input of your subject and your body. So in this video we're going to talk about how exactly we make this classifier and what kind of things you need to know in order to make it, and I've called it heimdall over here. So let's just take a test run, for example. So as you can see, we classified into any of these 6 categories. That's promotion, spam, social media, forum, verify code, and updates. Now, if for example we enter a spam email to try it out, you can see congratulations, you've been selected to win a free iPhone 15 Pro. Obvious spam email. And let's go ahead and click classify email for this email, and let's see what it gives us. So as you can see, we've gotten the prediction for all 3 different models that we use as spam, and next to it you see its confidence score is also mentioned. So we have naive Bayes, logistic regression, and random forest, and don't worry about these too much. As we progress in the video, we'll discuss about what exactly these models are and what exactly they do. And this is a basic Streamlit UI that I've made, which I will not be covering in this video because it's frankly not the point of the video. Anyway, so that's how this classifier works, and it's about 97% accurate. We're going to start with pandas and matplotlib, seaborn, string, and NLTK. So let me just explain real quick what these libraries do. Pandas is basically for your dataset operations, wherein you will analyze different data sets, you'll import them, you'll perform basic operations on them, categorize them. We use this basically for data cleaning. NLTK would be your natural language toolkit. We're going to use NLP concepts here for our email categorizer, basically to help us read text and actually convert it into numbers and predict and give outputs based on that. Matplotlib and seaborn are just for your bar graph and chart plotting. We won't be using it too much. And string is just for your string operations that we will see as we progress in the video. I'm also going to go ahead and download 2 other things from NLTK. I'm going to write nltk.download stopwords and nltk.download wordnet lemmatization. So let me just finish the import here. So from nltk.corpus import stopwords, and from nltk.corpus, one second, yes, .stem import wordnet lemmatization. Right, so don't worry about too much about this. This is mainly for cleaning, and when we get to it, I'll exactly demonstrate what exactly do we need these for. But basically, these are all the imports you're going to need, and later on we'll have some imports for the machine learning part of everything. Looks like I have an error over here. I've written seaborn in, it should be seaborn as, and let's run it again. And I think we're good to go. So all the imports are now done. So let me go ahead and show you what dataset we're going to be working on. So I've managed to find this online. It's basically a dataset with IDs, subjects, bodies, text, and categories, and category ID as well for a bunch of emails. So it has the 6 different categories that we showed at the beginning of the video. It has your subject and your body for each email. And something nice about this dataset was that it gave me the text column by itself. So normally you would have to make it by yourself, but here the text column is already there. Text column is basically wherein we combine the subject and the body into one column, which makes it easier to pre-process and clean the data before we work on it. Instead of working subject body alone, we have a column that combines both of them. So now let's go back to our model here, and let's get started with using the pandas library to basically just import our CSV file. CSV is basically our data set, the Excel sheet, and we're going to read it and make sure everything's perfect. So let's go ahead and do that. So I'm going to do df is equal to pt, that's our pandas import, dot read CSV, a basic panda function that lets you read any Excel sheet and store it in an object or in a data frame rather. So df is equal to pt.readcsv, and we're going to just type, I'm just going to manually type in the path for our data set over here. And I'm also going to just print the head. So we're going to do tf.head. This prints the first few rows of your data set. So as you can see, the data set's been imported. Let's also just go ahead and just print it in terms of the categories. So let's do print df category dot value. So what this is going to do, you'll just see in a second when I run it over here. Value counts. I think that's correct. Let me try and run this and check. Okay, I have an error of incomplete input. What is it? Okay, yeah, I'm missing a bracket. Let me try again. Yeah, so as you can see, it gives you a total count of each category and how many emails do we have. So our data set is pretty fleshed out and good. We have about 12,000 emails over here, and we have about 2,000 emails per category. So it's a pretty good data set, and I got lucky to find one. And it's always good to comment in your code, so I've just named this cell as reading the data set. Now let's move on to the next part. So now we're gonna basically initialize this stopwords variable. Stopwords is the library that we imported earlier, and what this is basically it allows us to sort of get all the English stopwords. Stopwords are basically words like is, the, all these words that don't really add too much meaning to the sentence, and the model can work much better without them, because otherwise it's like sort of noisy. So that's what stopwords is. So what we've done here is we've initialized a set for stopwords, and we've also initialized a WordNet lemmatizer. I'll get to that in a second. So let's just define our clean text function over here, and the input we'll take is text. And first what we're going to do is we're going to do text is equal to text dot lower, and that will basically convert all the capitals to small letters in our text. So that's our email subject plus body combination. We're going to first convert it to lowercase. The next thing that we're going to do is that we're going to join C for C in text, C not in string dot punctuation. Okay, so what this line here is doing is that we're basically removing all punctuation. So if any character has punctuation in it, if any text has punctuation, we return the text without that punctuation, because we don't need punctuation for our model. We only need raw lowercase text that's also split apart. So we're going to split every word. So if words are in the form of a large string, a sentence, we split it apart into individual words. Like hello world will become hello comma world, if that makes sense. And finally we're going to do words is equal to lemmatizer dot lemmatize w for w in words, if w not in stop words. So basically what we're doing is, if the word that we encounter is not a stop word, it's not like the, is, etc., we're going to lemmatize the word. Lemmatize basically here means to convert the word into the base word. For example, if the word is running, it will convert running into run, which is the base word. That's what lemmatize means, and that sort of helps the model clean out the text more and process it much better. Finally, we're going to do data frame of clean text is equal to data frame text dot apply clean text function, basically calling the function on our data frame, and we're going to store it into a new column called clean text. And let's go ahead and run this, and that should have run perfectly. I'm going to comment over here calling this the pre-processing. So that's about all that we have to do. So you can see the pre-processing is fairly simple, and that's in parts because of our Excel sheet being very well catered to our use case already. Otherwise you'd have to do a few extra steps, but regardless it's a pretty simple pre-processing and cleaning process here. So now let's move on to the next part, and we have to make an import here. We're going to do from Scikit-learn. By the way, if you don't have Scikit-learn installed in your Jupyter notebook, you will have to go and install it through the command prompt. So let's just go ahead and make our import. We're going to do import train test split. So this is a very useful, very commonly used ML function, wherein you will basically divide your data set or your data frame actually into a train test sort of split. You'll have 80-20. We're going to do an 80-20 split, wherein we're going to divide. So we have 12,000 emails, right? We're going to divide this 80-20 in the ratio 80-20 into training and testing. So we're going to do X train, Y train. Actually, this is like X train, X test, Y train, and Y test. So X is our input features, and y will be our output category. And we're going to divide our data set into training. 80% of the data will be used to train the model, and 20% will be used to test the model to make sure that it's accurate. So we're going to do train test split x, y, test size 0.2, meaning our testing will be about 20% of the total data set. We'll do stratify is equal to y, and random state is equal to 42. So this should ensure that our train test model splits our data accurately. And let's just go ahead and print and see what exactly the length of our training samples and the test samples look like. So I think I've made a mistake somewhere here because it didn't iterate properly. Let me just write length x test and see what's wrong. Let's go ahead and run this 1 second. Yeah, I missed a bracket, of course. I did not notice that. Problem with Python. Anyways, let's run this and it should give us... Oh, we have another error here. We have unexpected keyword. Okay, random state I think is not capitalized. Let's go ahead and do that. And add underscore and change the capital as well. I forgot that, yes. Let's do that. Half of coding turns out to be debugging. Anyways, as you can see, we have 10,000 emails, 10,781 to be precise, is our test training sample, and about 2,696 emails are our test samples. So that shows you the 80-20 test split that we've done, and that's decided by our variable here, test size is equal to 0.2. So that was for the train test split, and this is pretty important, and we're just going to write comments here for train test and split using Scikit-learn. Scikit-learn is a very useful library if you want to check it out and look at all the other types of functions and imports that they have. So they make machine learning a lot more easier. That's why we're going to use another Scikit-learn feature. And now we're going to do the actual machine learning heavy lifting part. What we're going to do is from sklearn.featureextraction.text, we're going to import TF-IDF vectorizer. So a quick note about what TF-IDF vectorizer is that it's basically an NLP, a natural language processing technique, wherein it converts all your different text that we have. So we had that email subject plus body text that we've pre-processed and cleaned. We are basically converting that into TF-IDF vectors basically. We're converting, so obviously a machine cannot read actual text, right? We'd have to convert it to binary. So what TF part of it does is it converts it into numbers. Each word gets a number assigned to it, and IDF converts these numbers into meaningful vectors. So each line, each sentence in our training data set gets converted into a vector of numbers, and all of these numbers have a different amount of score attached to it. So based on how important the word is, that gives it a score. So if you see here, we've written max features is equal to 5,000. This means we take the 5,000 most useful words, most unique words, most frequent but also most useful words that have appeared in the data set, and we are going to convert those into vectors and use that to train the model. And stop words is equal to English. Basically here we remove any stop words like the, is, and, etc. etc. We're going to do train x train. We're basically transforming the x train data. Basically the training data, we're transforming it into this collection of vectorized words with the most useful, most unique words, so on and so forth. And the test data, we're only going to transform it. We're not going to fit to it because we don't want to accidentally learn from the test data. And that's about what TF-IDF vectorizer does. It converts our text into vectors, and these vectors basically measure how important each word is in document compared to all the other training data set documents. Common words get removed and important useful words get higher scores. Now after running this, our training data should be ready to operate on. So now we're going to send this data into our actual machine learning model, and here's the actual heavy lifting of our machine learning project here. So let's go ahead and do fit models. I'm just going to write this, and the models we're using are the naive Bayes model. If I had to be more specific, it's the multinomial naive Bayes, and I'll get into that in a minute. The other one is logistic regression, and the third one is random forest. So what exactly are these three models, and why have we chosen these three models for our project today? So naive Bayes, multinomial naive Bayes, it works really well with word counts or TF-IDF type features. What it does, it assumes each word contributes independently. So for example, a word like offer or discount would be considered as spam. So it assumes that each word has importance and each word contributes independently. So that makes it very fast. That's the first model, but it also has its drawbacks. So we go to the second model, which is logistic regression, which basically is used for binary classification. Logistic regression classifies output into either yes or no type categories, just one or the other type categories. And here how it does is it basically takes weights of each different category, like spam or not spam. It assigns weights to every word, and based on the highest probability of weights, it decides whether it falls into yes or no category. That's logistic regression, and it's simple and interpretable, but it can also fall short quite a lot of times. So the final algorithm we use is random forest. So here I'm just gonna import all of these from Scikit-learn directly, and random forest is basically just a bunch of decision trees that can make powerful predictions. They tend to be able to handle complex predictions much better than, for example, logistic regression. And these are the three models, as you can see, we've used in the Streamlit website that we created. So I'm almost done. Let's just from sklearn.com import random forest classifier. So our random forest classifier, and these are the three models that we're going to use. We're going to create a dictionary here. This is a Python dictionary. We're going to initialize the keys as the names of our three models, and the values will be the function that we call, which will basically initialize these keys with these values. Logistic regression is going to be logistic regression. And random forest is going to be random forest classifier. So that's our dictionary created, and it makes it easier to handle multiple models with the dictionary. We can also create a results dictionary, and we're going to run a for loop here to actually run each model with our training data. So we're going to name comma model in models or items. We're going to do model.fit, and we're going to do xtrain TF-IDF. This is the vectorized training data set that we have fit and transformed earlier. We're going to do model.fit, and what this loop does is it runs on every single model and it fits it to our data, and basically it gives us an output of accuracy and stuff like that based on our model. So we're going to results of name is equal to model.score x_test_ TF-IDF and y_test. This is basically printing the confidence score of each model after we fit our data set to each model. And the for loop runs 3 times, obviously, because we have 3 different models. And we're just going to make a simple print over here for our results. So let's now go ahead and run this. And as you can see, our model output has come forth. Naive Bayes, logistic regression, they have a very less accuracy, and I actually didn't realize this until I edited the video. Until I went on later in the steps. So you'll basically see what I'm talking about. But currently the accuracy is very low because we've made an error much earlier on in the code. And see if you can spot the mistake. We'll discuss it once we get to it. Anyways, let's just keep moving on. And let's now write the accuracy score and confidence score code. So we're going to do from sklearn.metrics import, and we're going to import multiple methods. We're going to do classification report, accuracy score. I believe it's called accuracy score. We're going to do precision score. We're going to do recall score, and we're also going to do the F1 score. All of these are basically just accuracy measurements. It'll check based on your model's predictions whether it's getting everything right or not, and how accurately is it able to predict. So we're going to do results detail. We're going to create a dictionary, and we're going to do for name comma model in models.items, basically for each of the 3 models that we're running. We're going to do model.fit. x_train TF-IDF. It's a little typo there. y_prediction. This is our predictions per model. We're going to do model.predict x test TF-IDF, x test TF-IDF, and we're going to do results detail is equal to, and we're going to print out our different metrics. So we've just called each of these functions using our dictionary called results detailed over here, and we've put weighted averages as well as our test data from our model and our model's predictions, and basically comparing them using our weights to see how accurately our three models are performing. And now I'm just going to perform some simple print statements to actually view our output for the accuracy scores and classifications. And let's just now go ahead and run this code and see exactly what. Okay, I have an error over here. Okay, I think I forgot a bracket. And oh yeah, of course, our spelling mistake over here. Let's just fix that. IDF, and let's run. And as you can see, we have our precision recall F1 score over here, and if you notice, the values are not that great. We have 0.02, 0.15. This means the model's prediction on a scale of 0 to 1 is horribly low. And that's because earlier somewhere in the code, I actually messed up and I forgot something as small as a space bar. And then I don't know if you've got it earlier on in the video. I actually didn't realize it. And that caused the entire model to basically collapse. So I'm going to go ahead and show you where exactly we messed up and what we did wrong that ended up basically having a cascade effect and destroying every other thing in our code. So let's go up, and if you notice here, our text, when we print it, it prints out horribly, right? This is all gibberish text. What's happening is it's splitting every single letter is being combined into one single word. So this is what happens when you forget a small thing, as something as small as a spacebar. And now our training data set looks perfect. That's because we forgot to add a spacebar in the pre-processing step. Now let's go ahead and run all the cells once again. And you see now the scores are much better. We have 97 and 98% for each of the models. So now our precision and accuracy scores are doing much better than they were before. So now let's go ahead and just perform a basic test of our model with our own user added input and see how exactly our model performs. So we can do import re, and we're going to define a predict text function or predict email function, and we're going to pass our custom email through it and see how it works. So now let's go ahead and take user input for the email text. Next, what we're going to do is we're going to pass it through our preprocessing function. We're going to define a new variable email clean, which is the cleaned email, and we're going to run our preprocessing function on top of it. Then we're going to convert our cleaned email into a TF-IDF vector. So we're going to call our Vectorizer function, and we're going to transform our email into a vector for the TF-IDF process. Now let's go ahead and make our prints. So we're going to do model predictions /n, and we're going to print out each of the 3 models outputs on our custom user input. So our predict email function is ready, and what it does is basically passes all our functions into one function so that we can pass our own custom input. Now let's do predict_email, and we're gonna run this function. We're gonna call it. So let's go ahead and let's input any random email. Let's do a spam email. So congratulations, you have just won, let's say $1 million, and click the link below to pay now. And let's see how our model performs. And you see here that all 3 models have successfully predicted that this is a spam, and they each have different confidence levels. And if we added more data like a legit email, we would have gotten a high score. So let's just run through what we're doing in every step. We're basically first reading our CSV file. We're cleaning out the data, making sure everything's perfect. Removing putting it into lowercase, removing spaces between words. We're removing any punctuation as well. Then we train test split. We basically split our 12,000 emails into 80% 20% training to test ratio split. We then vectorize it using TF-IDF, import our models, and run 3 models, and then we just make our basic predictions. So that's about all. And this Streamlit UI I will not be covering in this video. It's a pretty simple one, but that's about it. I hope you learned something new, and thank you for watching the video. See ya.